Again, I'm Laura Lindsey. I'm the soybean and small grain agronomist, so I'm Osler's counterpart on the soybean side. Again, our Battle for the Belt project is going to kick off this year. There's 3 ways to follow along. We'll be going out to the plots, hopefully weekly, to track crop progress and growth stage, and also document any problems with weeds, diseases, insects, things like that. We'll also interview specialists. I see Horacio is on now. We'll interview Horacio about planting date and disease interactions because we know those can occur. So if you want to follow along to track the crop's progress and also hear from state specialists about planting date and management interactions, you can subscribe to our core newsletter. You can subscribe to our YouTube channel, which is in the middle here, or either follow Osler and I on Twitter or the Ag Crops team on Twitter. So we have 3 Twitter accounts that will have all of these videos posted as well. So we know that soybean planting date is the #1 factor that influences soybean yield. And I think I've shown this slide, I know, in the past before, but just as a reminder, we know planting date is extremely important. We surveyed farmers. This was, I think, 2015, 16, and 17. All these red dots are surveys, paper surveys to farmers asking about all kinds of management practices, planting date, relative maturity, seeding rate, pesticide applications, all kinds of things. And across the whole Midwest region, the #1 factor that influenced soybean yield was planting date. These graphs show the days planted after April 1st versus soybean yield. This first box here, this is the northern portion of the state. So during the years of this study, there was a 1/2 bushel per acre per day reduction in soybean yield for each day planted after the end of April. On the central portion of the state, during these years, it was only about 1.5 bushels or 0.15 bushels per acre per day for each day planted after the end of April. This area of the state was drier, so we do see planting date play into water availability, especially during the R3 to R5 growth stage. We know that's when soybean plants need a lot of water to maximize yield. So sometimes planting date doesn't matter as much, and that tends to be in years where water is limiting between the R3 and R5 growth stages. One thing I wanted to bring to your attention, since this is soybean management for 2023, one thing that's changed recently are the crop insurance early planting dates for soybean. So this is the revised map. So in Northern Ohio, the new dates are April 15th. This yellow area, I guess more Southern to West Central Ohio, the date is April 10th, and then Southern Ohio is April 5th. I believe this is about a 9-day earlier planting date. So I just wanted to bring that to your attention. And part of the reason we were able to ask RMA to relook at these planting dates was due to this paper survey. So this paper survey was funded by the NCSRP, so the North Central Soybean Research Program checkoff. And so we had a ton of soybean yield information and planting date information for the Midwest. And so we were able to look at that closer. And then a group of agronomists, we wrote a letter to RMA to ask them to relook at early planting dates. So which brings me into my next point. We are again asking you to help us with a survey. So these paper surveys are a way for us to gather a huge amount of information. Field work is extremely tedious, and we're sometimes limited where we can go and what we can do. But the paper surveys are really a nice way to get a lot of information and get data for the state of Ohio. This is also funded by NCSRP, and this is being led by Sean Conley at University of Wisconsin-Madison. And he developed a survey to look at all kinds of management practices, everything that you should know fairly easily: planting date, harvest date, seeding rate, variety, seed treatment, things like that. And his idea is to develop an online cropping tool where we can look at all of this data and then also weather data in soil data. So if we have your field GPS location, we can pull those factors as well to develop a tool that farmers can use throughout this region to optimize their cropping system. So we are in the second year of this project, but still the very beginning stages. So this is really when we need data. So there's two ways you can share data with us. The first is this QR code will take you directly to an online survey. Before you go on that survey, you want to make sure you have your field average soybean yield, as well as your baseline management practices. Again, planting date, relative maturity, variety, seed treatment, herbicide application, things like that. I also have a paper survey. If you want a paper survey or a PDF I can email, just let me know and I can provide that to you. So we really need data from Ohio to make this tool relevant. Sean Connolly is going to develop this tool with or without us, right? Since it's a North Central project. So if you want the data to be useful to you as a farmer, please fill out the survey when you get a chance, or if you want to ignore me and fill out the survey now, that's fine as well. But please, if we could get some data for Ohio, that would be super great. So in terms of planting date, one thing I've been thinking a lot about is how early is too early. As Osler mentioned, sometimes there's not a lot of days we can plant in May. And so is it better to go a little bit earlier into April because the soil is dry enough and maybe it's not ideal, but at least something is in the ground? Because if you wait, sometimes that water turns on in May and now you're looking at a June planting date. And we know June is not usually ideal. There are some years where soybeans planted in June will out yield soybeans planted in May, but that tends to be timed with rainfall, again, at that R3 to R5 grow stage. If you plant late and that rain comes late, you can actually have high yields for June planting, but again, it's not ideal to plant in June. So I talked a little bit about this study last year, but now we have 2 years of data. 2021, 2022, we looked at planting date and cover crops. And so we had 3 target planting dates: ultra early, which I considered the first week of April; early, which was the last week of May; and then normal, which was mid-May. And then we had 3 cover crop treatments because we really wanted to see if you could plant earlier, maybe with a cover crop, if the soil was drier, things like that. So we had 3 cover crop treatments, none. Rye terminated early. So this is what it would look like terminated early. So we planted into a dead cover crop, and this was terminated with herbicide about 1 month before planting. And then rye terminated late or planted green. So we planted into a living cover crop and then terminated within 1 week of planting. So this study was done at 2 locations in Worcester, Ohio on the Worcester campus, so Northeast Ohio, and then South Charleston at the Western Agricultural Research Station in Clark County. So these, locations aren't that far apart, but from north to south, there are some climate differences or weather differences, with the northern location being a little bit cooler in the spring and taking a little bit longer for the soils to warm up. So I'm very pleased with this study. Usually we don't get planting dates to be consistent across years and locations, but this study had that. In terms of the cover crop, at all locations in all years, we planted April 14th or October 14th or October 15th. For ultra early, we were targeting that first week of April, which we did, with the exception of Western South Charleston. In 2022, we planted March 30th. I believe that was the window. If we would have waited, the window would have been gone. Early planting, we were, again, very consistent with that last week of April. And then our normal planting date, remember, we were targeting mid-May, but mid-May just seems like a very challenging time to plant because that's when we get rainfall. So our mid-May planting date was bumped back to the last week of May, which is very common for Ohio. I'm not going to talk too much about cover crop biomass, but we did have different termination timings based on planting date and just whether it was a dead cover crop we planted into or did the planting green treatment. So basically here, the later we terminate a cover crop, the more biomass you get. So if you want to have a large amount of biomass, maybe for weed control or something else, terminating later will give you more biomass. So I'm going to talk about Northeast Ohio first. Again, this is Wayne County, Ohio on the Worcester campus. These are some pictures of the first year of the study. These soybeans were planted on April 6th, and I went out about 6 weeks later just to see what it looked like. It was pretty ugly. So what I saw were soybean plants with no cotyledons. I think I saw a little bit of bean leaf beetle damage on the cotyledons, soil crusting. So this soybean here is stuck. When you plant really early and the soils are cool, the weather is cool, it can take a while for those plants to emerge out of the ground. And so that gives opportunities for the soil to crust over. You can also see the hypocotyl is damaged. It's brown, black colored. That could have been freeze damage. 2021, there were snowy conditions in May in Worcester. I don't have a picture here, but I also believe there was slugs, very likely, because I just saw some plants that were just clipped off completely. So multiple issues in Worcester, Ohio with those really early planting dates, which I think would be expected. In terms of stand counts, these are stand counts of the soybean plants in June. So we waited till everything emerged in June to get a good stand count. So this is the first year of the study, and what you're looking at are our ultra early planting date. So first week of April, early planting date, which is the last week of April, and normal planting date, which is the last week of May. Ideally for soybeans, we'd like to have a stand of at least 100,000 plants per acre. In this study, we seeded at 120,000 seeds per acre, which is a little bit lower than what I would normally recommend. But we really wanted to test the system to see if the cover crop could protect soybean plants if we planted really early. And this black horizontal line is 50,000 plants per acre. If soybeans are relatively evenly spaced in the field, that's our replant threshold. I know that's a very loaded statement by saying they're evenly spaced. We know that doesn't happen, but our replant threshold is surprisingly low. And so what we see with our stand count data, when we have no cover crop and planted the first week of April, our stand was 80,000 plants per acre. So this is lower than what we'd like to see, but 80,000 isn't terrible. But when we had a cover crop, our 80,000 plant per acre stand was reduced to 20,000 plants per acre. So that's a 4-time reduction in plant stand, whether we had early terminated or late terminated cover crop. For our early planting date, this is the last week of April. Stand was very low. It was hovering around 50,000 plants per acre, but it was consistent whether we had no cover crop or a cover crop. So no cover crop effect for the end of April. And then for our normal planting date, again, this is the end of May. Our highest stand was when we had no cover crop. And then we had reduced stand with a cover crop, but not that low. For early termination, it was about 80,000 plants per acre, and then dropped down to 60,000 for planted green treatment. With late planting and late termination, we get a lot of biomass. So there could have been some issues there planting into that large cover crop. The second year, 2022, it's interesting because our stands are differ because it's a different growing season, but the trends are very, very consistent. So when we planted the first week of April with no cover crop, our stand was 50,000 plants per acre, but similar to the first year of the study with a cover crop, we dropped down to 20,000 plants per acre. Very similar to the first year of the study, with that early planting date, there was no effective cover crop. So stand was the same regardless of the presence of a cover crop or not. and overall higher than the first year of the study. And statistically, no difference for that late planting date either. But stand is one thing, yield is a different thing. So we also have yield data. This is again Worcester, Ohio, the first year of the study. Anything with an A is statistically same in terms of yield. So our highest yielding treatments were indeed that first week of April, as long as there was no cover crop. When we had a cover crop, our yield declined. For our mid-May planting date, yields are statistically, not mid-May, last week of April planting date, our yields are statistically the same. And then for our end of May planting date, our highest yield was no cover crop. The second year of the study, again, trends were similar. So anything with an A is statistically the same yield. So that end of April planting date yielded the same, whether there was a cover crop or not. We also had statistically the same yield when we had the end of May planting date and the early termination treatment. Our ultra early first week of April planting date was not as high as it was the first year, but still closer to 60 bushels per acre, where when we had a cover crop, it dropped down to 25 to 35 bushels per acre. And these are our stand counts, just as a reminder. And what I think is interesting, if you remember, stand from that first year was hovering around that 50,000 plant per acre mark. And our yields were between 70 and 75 bushels per acre. So I know 50,000 plants per acre makes people very uncomfortable because it can look really, really bad. And you may want to replant depending on how evenly the plants are in your field. But in research, we can leave things go just to see what happens. And with 50,000 plants per acre, statistically, we were getting the same yields as a higher plant population, and it was around 70 bushels per acre. So I think that's pretty remarkable in itself. So the second location is Clark County. Clark County soils tend to warm up a little bit quicker in the spring. These are some pictures of the first year of the study. Across the top, you're looking at April 7th planting dates with no cover crop, early termination, and then planted green. And then the bottom set of pictures are our last planting date, which was May 27th, again for no cover crop, early termination, and planted green. And I'm showing this just so you can see the amount of cover crop biomass that's still there. These pictures were taken on July 8th. So you can see the cover crop biomass there. And you also see the lower stand and more uneven stand for that early planting date, where when we plant later, we do get a more even soybean stand. These are the exact same plots though, in September 9th. So a couple months later, what you'll notice is those gaps are gone. Again, soybean plants can compensate really well for low plant populations. So with these lower plant stands, we usually just see more branching because that's the way the soybean plants can compensate for low populations. In terms of actual numbers though, these are the stand counts from the first year of the study. At this location in year, there was no interaction of planting date and cover crop. So I'm showing those factors separately. So with planting date, we do see lower plant populations when we plant in April, a little bit lower than 80,000 plants per acre, going down to maybe 70,000 plants per acre, and then higher plant population with a later planting date. In terms of cover crops, there is maybe a few differences here. 90,000 plants per acre with no cover crop and dropping down to maybe 70,000 plants per acre for early termination. So overall in South Charleston compared to Worcester, our plant populations were higher. Yield though, again, there was no interaction of planting date and cover crop. So here you're just looking at planting date. So whether we planted the first week of April or last week of April, yields were the same. And those were about 75 bushels per acre. So no additional advantage to planting the first week of April versus the last week of April. But we do see a yield decline when we go out to the end of May. As a reminder, our stands are here. So even though our plant populations were lower for early planting, 65 to 70,000, 75,000 plants per acre, our yields were greater. And so this is just kind of important to recognize that planting date is more important than seeding rate to some extent. Certainly if we go really low, there's a problem. But if we can target 65, 75,000, 80,000 plants per acre with an early enough planting date for the plants to compensate through increased branching, plants can maintain their yield in spite of having lower plant populations. Cover crop effect, the first year though at South Charleston, there was none. So whether we had one or not, yields were all the same. This is the second year of data, 2022 in South Charleston. This year there was an interaction of planting date and cover crop. So I'm showing both of those factors together. Again, anything with an A is statistically the same. So remember, ultra early this year was March 30th. So March 30th in South Charleston or Clark County, Ohio, with no cover crop, we were getting close to 80 bushels per acre in yield. But with the cover crop, our yields went from 80 to about 50 to 55 bushels per acre. So fairly large drop. If we look at just an early planting date, so end of April, statistically yields are all the same, and the same as that March 30th planting date. But we do see some yield declines with our end of May planting date. And these are our stands. So no cover crop for March 30th planting date. Our stand was reduced to 70,000 plants per acre, but not as much as when we had a cover crop. With the cover crop, we were down to 34 to 48,000 plants per acre. We were right around 70,000 plants per acre for end of April planting, and then higher stands for our May planting date. So the key takeaways of this study, soybean stand will likely be lower for early planting, especially if you have a cover crop. So without a cover crop and you're planting early, we'll probably have 50 to 70,000 plants per acre, with the lower number being in Northern Ohio. But with a cover crop, we saw plant populations decrease quite a bit to that 20 to 48,000 plants per acre range. In Northern Ohio, I think planting the first week of April is risky. The first year of the study, as long as we had no cover crop, it was fine. But that second year of the study, 2022, the first week of April, seemed to be too early. But as long as soil conditions are okay, end of April would probably be fine for Northern Ohio. For West Central Ohio, we could plant successfully the end of March in early April, as long as there was no cover crop. But there was no additional advantage for that really early planting date compared to the end of April planting date. Those were yielding the same as long as it was April. And really one of the other big key takeaways for this study for me was how good soybean plants were at compensating for low plant populations, maintaining high yields, even though the population was 50,000 plants per acre. So that was truly amazing for me to see in this study. And this study was funded by Ohio Soybean Council. This is my graduate student, Seth. So he's been working on this project for 2 years, and he's going to hopefully graduate in about a month or so. So one other thing I wanted to talk about. Oh yeah, go ahead.
You have a couple of questions in our Q&A. The
Perfect.
one question kind of came up as you were talking about stands. How do you know, as far as your stand counts, that it's not just that they just haven't germinated yet in those early planting dates?
Yeah, so that's a great question. So I'll show Seth again because Seth helps me answer this question. So Seth, I had him do stand counts every other week throughout the entire growing season. And I didn't show that data, but we do see lower populations with the early stand counts because, as you mentioned, the plants just weren't up yet because it was cool. But the stand count data I showed was all for probably, I'm guessing probably the end of June. I don't have the exact date, end of June, and that's when more of the plants were up. But we do have stand counts from May through harvest time. So we have that data. So, but we tried to take the stand that I showed was when early in the season, but when everything should have been up.
Okay, and then the next couple of questions, kind of I'll put them together. One was, did you have a seed drop rate in the bean trials? They'd like to know that, as well as what was the seeding rate for your test?
Yeah, so the seeding rate for this was 120,000 seeds per acre as our target. And that is lower than what I would recommend a farmer go. But we wanted to test the effect of the cover crop on soybean stands. So we went a little bit lower than what most farmers would plant. When we plant our soybeans in other studies, we are usually targeting 140 to 150,000 seeds per acre as our seeding rate. So that's what I would recommend for anyone planting at a normal time in April or May. If you plant into June or July, then a much higher seeding rate would be needed. And I don't see any other questions about that study, but if you have more, feel free to keep typing. I'll move on to one more other study. I have about 15 minutes that we've been working on. So another thing of interest, I guess, in 2022 that came up quite frequently was, I guess, renewed interest in small grains. And this was driven in part by high wheat prices. So this is the squares here show the wheat price trend. And there was an uptick in 2022 in the price of wheat. We also saw an uptick in the price of soybeans. We know inputs, though, fluctuated as well. So even though prices are higher, inputs in many cases were higher as well. But in 2022, one trend I saw was renewed interest in wheat in general, and then also wheat and double crop soybean systems because the prices were high. So we know that there's a lot of value to having small grains in rotation with corn and soybean. First of all, having that third crop in rotation helps diversify the cropping system in general. It can help lower disease and pest pressure. Winter wheat in particular helps reduce soil erosion just by having a fall cover on your field. And in our research, we have research in Wood County and Clark County, both looking at corn, soybean versus corn, soybean, wheat rotations. And when wheat is in rotation with soybean, on average, it can fluctuate, but on average, there's about a 4 bushel per acre increase in soybean yield just from having wheat in rotation. But one trend in Ohio over the past, I think this is 20 some years, is that there's a decrease in the number of wheat acres planted. Usually I ask people why, but this is hard on a webinar. I started in 2012. So at first I thought, maybe I'm the person who's killing the small grains in the state of Ohio, but it's not. It had nothing to do with me. It just happened to be right when I first started my position at Ohio State, those wheat acres really started declining, and that was related to prices. It didn't make economic sense to a lot of farmers to plant winter wheat, so we saw that decrease in acres, but now there's a little bit of an uptick due to recent prices. So one thing I've been working on quite a bit in the last 10 years at Ohio State is how can we couple wheat with something else, such as soybean, to improve overall profitability of cropping systems. So this is a study that was done a few years ago in collaboration with Eric Rieker. He was the former Fulton County Extension educator who's just been recently promoted to a field specialist. But this was his idea to compare full season soybean to relay-intercrop soybean to double crop soybean. Just for reference, our study was up here in Northwest Ohio in Wood County. Generally speaking, this is our South Charleston location. Generally speaking, if you are in central to southern Ohio and you're growing wheat, double crop soybeans are probably something normally you would do. But once you move further north, it's a little bit more risky, and prices really have to dictate whether or not you want to plant double crop soybeans. So this is just focusing in Northwest Ohio, but our normal practice for wheat would be 7.5-inch rows width, and our recommendation for seeding rate would be 1.5 to 1.7 million seeds per acre, as long as you're planting within about 2 weeks of the county Hessian fly free date. For full season soybeans in that area, usually mid to late May planting, although in recent years, especially, it might have been June because of wet weather. 15-inch row width would be standard. For this study, we used a 3.1 relative maturity and a seeding rate of 150,000 seeds per acre. For relay intercrop, I put standard practice because it can vary. But in Northwest Ohio, what you would do would be plant wheat in 15-inch row width and at a lower seeding rate. So we cut the seeding rate in half when we go out to wider rows because we're doubling the row width. So for this study, it was about 870,000 seeds per acre. And then we intercrop soybean before the wheat is harvested. And in this study, that was the last week of May into early June. And those soybeans were then in 15-inch row width in between the wheat rows, which you can see here. And for consistency, we also used a 3.1 relative maturity, the same variety. So double crops, wheat can be grown in those narrow rows because you're not putting soybean in between the rows. For double crops, we like to target no later than the first week of July if possible. And they can be planted in 7.5 or 15-inch row width, depending on what planter you have. For this study, we used that 3.1 relative maturity and then a higher seeding rate. So as Osler mentioned, with soybeans, as you plant later, you want a higher seeding rate. So this is data for the 3 years, I guess cropping year, which starts in the fall with wheat planting. And we looked at several different systems. I'm just going to focus on the ones that involve full season wheat or just wheat alone, and then the relay intercrop and double crop systems. So this graph is showing wheat grain yield for the 3 cropping years and then the 3-year average. So the red bars here are the wheat yield, just standard wheat, narrow rows, no intercropping. On average over the 3 years, yields were 90 bushels per acre. When we go out to 15-inch row width, even with no intercropping, but just go out to 15-inch row width, we do see a decline in yield to 80 bushels per acre, and that's strictly due to the row width effect. Other studies more in central or maybe southern Ohio into Kentucky, there's less effective row width, but in this study, we saw about a 10 bushel reduction in yield going out to wide rows. And then wide row wheat plus those relay intercropped soybean in between the rows, our yield was reduced again to 70 bushels per acre. So here there's that row width effect and also some mechanical damage to the wheat as we're intercropping soybeans. In terms of soybean yield, the red bars here, those are our full season soybeans. So in the study, the 3 years planted May 25th, May 6th, and May 24th. But on average, the 3-year average yield there was about 55 bushels per acre for full season soybean. When we do relay intercrop soybean, planting date may be a little bit later. And also those soybean plants are competing with the wheat that's already in the field and actively growing. So our soybean yields are lower in a relay intercrop system. And that was about 35 bushels per acre. And then when we moved to double crop soybean right after wheat harvest, our yields were, as I guess on average, 20 bushels per acre. Again, this is planting soybeans in Northwest Ohio that first week of July. You can see the first year of the study, 2016, when we planted double crop soybeans, they were planted early. It was July 1st, but 2016 was a really hot and dry year. And we knew that going into July, it was dry. So when soil moisture is limiting, double crop soybeans are going to yield lower. The second year, 2017, there was better moisture and we were getting close to 30 bushels per acre on double crop soybeans. So yield is one thing, profitability is another thing. And so recently, this is something we've done in the past year, was create a partial return calculator. So this calculator uses data from our field study in Northwest Ohio, but current prices. And so we looked at prices, I think it was fall of 2022 as our default value. So if you want to download this calculator, it's on my website here. It's an Excel file, and you can also go there with this QR code. But basically, this Excel file has several tabs. We have our default values here. And again, these are prices based on Ohio State's enterprise budget or custom rate surveys. And then our default values for soybean and wheat yield in the various systems are from that field study that I just discussed previously. And then any cell that is highlighted yellow is something that you can change. So you can compare the system using our default values, but we know prices fluctuate a lot. So you can also put your values in as well. And then the second tab will show the gross return, costs, and partial return for our default values, and then your values as well. The third tab shows or estimates nutrient removal. If you are in a more intensive cropping system where you're harvesting soybean grain, wheat grain, and potentially even straw removed from the field, wheat straw, we know that you're also removing P2O5 and K2O, so phosphorus and potassium. So these values here are estimating the nutrient removal, P and K removal in the wheat, grain, and straw, and then also soybean grain. And these removal estimates are based on our tri-state fertilizer recommendations. And we can put an economic value to that P2O5 and K2O removed from the field. And that's what this last tab in the Excel file does. And so you're looking at gross return, the cost, and then partial return. Then from tab 3, we subtract out the nutrient removal value, P and K. And then it sorts by, I guess, color. Anything green is higher partial return, and then red would be a lower partial return. So using our field data from Northwest Ohio, and then prices that were current in, this was end of September of 2022, in terms of economic return or partial return, the highest, I guess, most profitable in terms of partial return was that wheat grown in 7.5-inch row width, followed quickly by that double crop soybean, and then selling the straw as well. In terms of economic value, there's a lot of value in selling that straw. So that study was funded by Ohio Corn and Wheat. So I thank them for their support, and also Eric Rieker, since it was his idea as well. Are there any questions? I have more slides. I never know how many extra slides I should put in, but I can pause for a minute if there's questions. I know I'm getting close on time. All right, my next set of slides are
questions. Yeah.
I say my next set of slides are pretty quick, so I'll give a chance for people to type as I go through. The next is more just updates as a soybean team in general. So if you guys haven't heard of the Science for Success team, I'm just going to talk about that real quickly. So the Science for Success team is funded by United Soybean Board, and this funds groups of agronomists across the United States to work together on collaborative extension deliverables, not research, but extension. And so I just wanted to show you some of the resources we have. This is called Science for Success. And the goal is to deliver best management practices to soybean growers across the US, and summarize some of our ongoing state checkoff soybean funded projects, and collaborate on national research trials, and then convert those into extension deliverables, either fact sheets or webinars. We did some things on Twitter last year. So this is a really good resource if you're not familiar with it. And I see questions popping up, so I'll pause on this to answer questions. But if you want to see any of our Science for Success information, we have information on growth stages, replanting, equipment for planting. You just scan this QR code and you'll be able to get to those resources. So